Alright, let's jump in. We're going to start with a project a shapefile. The first task is to populate the geodatabase with starting data for the analysis as needed. We will convert the data format from shapefile to geodatabase and project it to the state plane coordinate system. Now we open the data requirement table, which is go back. I even don't know where did I put it. Where is my data source? Oh, right here. Okay, data. So zoom in. Okay. So here we will convert the data format to shapefile, and we will look at the various preparation tasks in mind as we're working through the project. We can reference it. So using Windows Explorer, open the data requirement table from the Map and More folder. So if the table isn't up to date, download the results. So I have it now. Most of the data sets need some preparation. Actually, if we count format conversion and projection as preparation task, they all do. So for now, we will start with a dataset that doesn't have anything listed in the preparation column. So the block Centroid dataset in row 11 is 1, which is right here. Okay, I'm gonna drag it here a little bit more. Okay. And minimize the data requirements table. So now we have our project here. Insert a new map and name it Lesson 4A. So I'm gonna go to Insert New Map. So now we are inserting a new map. We will do is that, okay, insert a new map that I'm going to go to Maps and name it Lesson 4A. So as an alternative to using the Insert tab, trying to right-click the map folder in the project pane and click New Map. So yeah, we can do New Map next time then. Open the Project tool. So first of all, we will check the coordinate system of the block centroids layer to make sure it must be projected. So we will do lesson 2. I don't have a lesson 2, but it's okay. So in the contents pane, we will click the centroid and click property. So if we do not have, I can just do lesson 3. And oh, I don't need to. Okay, because I have a lesson 3 open here. So right click on it, go to property and go to cancel right here, property, coordinate system, California 04. Okay. Let's see, spatial reference. Go back to general and the block centroids. So we have this, and let's go to block centroids. Oh, I don't have it here. Let's go back. Folder. Let me just add it. Block centroids. It should be in sensors. I'm sorry. I just want to clip everything to open it up. Alright. So I have everything, just like cooking. I put everything that I can add. Okay, now I have a block centroids. I'm gonna zoom to layer and right click on it again and go to property. and then go to source and spatial reference. So we will see GCWS 1984, and we learned this a lot. So the the geographic coordinate system is GCS WGS 1984. We will project to the state plane coordinate system. This isn't an on-the-fly projection of a layer in a data frame, but a geoprocessing operation on the feature class itself that converts all the WGS 1984 angular coordinates to state plane linear coordinates. So, we need a geoprocessing tool to do it. We will close the layer property and close here. I'm gonna just save it, okay? And if necessary, we will return here by clicking the tab above the map. And on the analysis tab, we will do geoprocessing analysis and geoprocessing, and we will click tools, display the geoprocessing pane. So open geoprocessing pane is here, and so the gallery of common tools right here, gallery of common tools. Switch between favorites and all boxes, toolboxes here. Favorites are here. So the analysis tab and the geoprocessing pane allow we to access literally hundreds of tools for any number of tasks. And the most common two are displayed in the gallery across the top of the ribbon. So this is the ribbon, and top of here, the gallery is right here. And can customize to include the tools that make the most sense of the workflow. Also notice that the geoprocessing pane initially displays favorites tabs. At the top of the pane, this tab is also customizable. So in the geoprocessing pane, we will click the toolbox, which is right here. And this pane displays all the tools included with ArcGIS Pro organized logically into toolboxes. There are a lot of them, but most are specialized. So the ones most useful to the project and to much of the typical GIS work are the analysis, conversion, and data management toolboxes. So we expand data management tools, then expand the projections and transformations toolset, and click the project tool. Click open the project tool in geoprocessing pane. So data management tools, and then we have start with the project, transformation, and project. So batch project. Okay, last time, this is the raster. So raster, cool. Last time I checked, there was not many tools in here, so I'll just open project. So most tools basically the same as this one. So a dialog box with several settings called parameters. So those are parameters. So require parameters such as the input and output datasets for feature classes, and the output coordinate system are marked with a red arrow stick. So we have to put. So those are must put, okay? So those are the required parameters. So required parameters such as this input and output or feature class, the output coordinate system are marked with a red asterisk. So the ArcGIS help panel summarize the tool's function. This tool takes an input dataset and creates a new output data set in whatever coordinate system we choose. So in the upper corner of the pane, we will click the help button. So help button is like this now. You hover on top of it, and then it shows the detail about the tool and usage, and we can of course we can click this. So and then we have this. So everything we can read about. I'm not gonna go over. So on the web that you click, and then this thing will pop up. And now we will project the block centroids shapefile. Okay, so now I'm going to bring the data. So our data, I'm gonna go to database, and in here I don't have it here. So now I'm gonna go back to folders. So it's in the source data census centroids and click OK. And output, of course, I will put it in my database. Okay, click open. So Riverside geodatabase. Okay, and output data set, and I already put the location. So, but I have to give a name. So, okay, database, I have to give a name. So our name will be block centroid. And click save. And the coordinate system that we will do, we already did this. Open details help, we already did that. So that parameter information windows help decipher the parameter names, which can often be rather technical or cryptic. Cool. Okay, so we click the browse button. So and the icon changes. It's right here. Browse. And on the right of the parameter, click Open a Browse dialog box. Click the folder item on the left of the dialog box, and then we browse to the site park size, source data, census. Double click the block centroid and add it to here. So which is right here. And once we drop the input data set in place, ArcGIS Pro can fill out some of the other parameters for us. So it reads the input coordinate system CS WGS 1984 from the metadata and directs the output to the default geodatabase. So this geodatabase is where we want the data to go, but it is not the feature class name we want. So in the output, I navigated to the to our Los Angeles River Park Site Project geodatabase. So next we will, for the output coordinate system parameter, we click the select, which is this one, select coordinate system button. Expand the projected coordinate system folder, then we will go to state plane. So state plane. And from state plane, we will go to the NAD 1983 International US feet. So US feet. Okay. We expand it, and be careful to use the 1983 folder with that exact name. So several other versions of the name look similar, such as the 1983 and then 2001. So let's find it. So 1983, there should be a 2001 down somewhere. Oh, we do not. But I remember there were, okay, right here. So it's this folder. So we see the 2000. Oh, down is the 2000 folder. They combine it all the way here. Let's see. Earlier I saw the 2011 one. Okay, I don't see it anywhere. Okay, right here. So USV. So not this folder, it should be this folder. So we scroll down and click 1983 State Plane California V. California V, V means 5. This is 6. Okay, and 0405 US feet, and click OK. Because the input and output data sets have a different geographic coordinate systems, GWS 1984 and NAD 1983 respectively, a geographic transformation has been listed automatically. When we project layers on the fly, we can bypass geographic transformations, but the project tool makes us to do them. So the default transformation chosen by the ArcGIS Pro is usually the best choice. In this case, WGS 1984. ITR F00 to NAD 1983, there may be times when we want to use a different one. So for example, to conform to standard practice in the organization, in this case we will keep the default instead of changing the transformation, but be aware that we can change it if necessary. For more information, that we will see the data. So we will check the project tool setting against the figure and click Run. So which is right here at the bottom of the geoprocessing pane. When the geoprocessing is completed, the new block centroid layer is added to the map, and then it's running. So now it's added to the map. So the block centroid feature class with the coordinate system we specify also have been saved in the Los Angeles River Park Site Project Geodatabase. Now we're going to close the geoprocessing pane by pressing this X in the upper right corner of the pane. So if necessary, we will zoom to the block centroid layer. So in the project pane, expand the databases folder. So if necessary, which is right here. So our block centroid projection is here. In the project pane, click database folder. If necessary, and expand the project geodatabase. Confirm that the new block centroid is present. So which is right here. So if we don't see the feature class listed, right-click the database in the geoprocessing pane and click Fresh or F5 on the keyboard. I don't know, it's F5, but now I know it's easy to learn. Okay. And we confirm that the coordinate system of block centroid is state plane, California Zone 5, and its geographic coordinate system is GCS, North America 1983. So right click, go to property, and go to source, and we will see spatial reference. It's NID 1983, state plane California 5 FIPS 0505. So GCS, I think it was datum. Yeah, the geographic coordinate system 1983. So the datum is the D North America 1983. And now we open the map properties of the lesson 4A and set state plane California 5 as a favorite coordinates by clicking Add to Favorites on the right of the projection. So click OK. So this is the map property, and this is the favorites will be this one, not the web locator, unless we publish web map. So we add to the favorite, and setting favorite projection saves the projection to the favorites group, so it is easier to find. And we click OK on the map property dialog box. On the analysis tab, we will click history. So analysis tab, history is this one. So now for history, that I did a lot for sure. So now it shows that today I run this tool. So the project pane opens the right, showing the geoprocessing history. All geoprocessing operations are logged here in a list displaying which tools were run at that date and time, along with any success or error messages. Hover over project to see more details about tool parameters. Results are especially useful when a process fails because the error is reported in the messages section. We can reopen and rerun a tool with all the parameters already set. From this list, simply double-click or right-click the tool and click Open to open the tool. This is a convenient way to rerun the tool if we want to simply change a parameter or need to return the tool for any reason. So, let's see, catalog, project. So, history is right here. So, it's not beneath it. Geoprocessing history project and geoprocessing history. I don't see there anywhere. So, processing history. Nope. I think history they move it here. So, it's different from the book. Let me drag it down. So, yeah, nope. I don't think. Nope, the geoprocessing history is right here. And then you can click this one. So reduce the geoprocessing history item in the project pane. So we will add a feature class to the Los Angeles River Parkside project geodatabase using the copy tool, which is neat. So now we will use the copy tool to copy the land park feature class to the project geodatabase. So now we're going to back here, and it's a useful skill setting the geoprocessing environment. Environment settings are default values or conditions applied automatically to all geoprocessing operations. So I'm gonna just leave it here. Go back to project, portal, favorites. Cool. I don't have any favorites. So we will make a copy of there, and I don't want to. So now we're going to set the geoprocessing settings. There are many environment settings, but we will concentrate on the output coordinate system. So on the analysis tab, we will go to environment. So for the environment, so that which opens the environments pane. In the output coordinate system drop-down list, click block centroids. So output coordinate system. So go to output coordinates. So I'm gonna do is block centroids project. Yeah. This will apply the coordinate system from block centroid that we define here. So output coordinate system we did. Okay. And this is really neat for the ArcGIS Pro. I don't have to come back here to set the settings, so you can find the file and everything. So now you change it into NAD 1983 State Plane, California. Now we're going to copy the parkland. The parkland feature class is in the WGS 1984 geographic coordinate system and must be projected. So on the analysis tab, we will click the tool button to display the geoprocessing pane. So click OK, and then not environments anymore. So we can double check. Yep, everything's there. Not ready to use tools right here. I'm gonna find this time is we will just go to search. So search, I will say copy. So copy, we have a copy features. Click copy features. So we did just geoprocessing pane search box above the tool list. We type copy as we type ArcGIS Pro presents a list of possible matches. So we click copy feature tool, click the browse button on the right of the input. So input is right here, and browse. We're gonna browse to our parameter. So open the browse dialog box and click the folders item on the left of the dialog box, and then browse to the park site. So I don't know where's park site. Park site. And then we go to source data and Israel geodatabase, and then open and double click the landmark. So parkland, and we will click OK. So to prepare the data, it might take a couple of months, and it depends your surveyor tool. And once they have the data, I have to input in the geodatabase and the attributes. So for output feature class, we will type so it's in our geodatabase for sure. So parkland, and then we will say parks, and then parks and regional. Okay. So we have a parks and regional, so that, and then I will click run. So for output feature, we did park regional, confirm that the feature class is saved to the Los Angeles River geodatabase. I did, and track the project tool setting against the figure, and click run at the bottom of the geoprocessing pane. So when the process is completed, the new parks regional, which is right here, this layer is added to the map. And the park regional feature class with the coordinate system we specified has also been saved to the Los Angeles River Parkside project geodatabase. Thanks to the environment setting, the park's regional feature class was also projected to the state plane coordinate system. As long as that setting remains in place, which it will within the current project until we change it, any geoprocessing tools we run will also cause the input dataset to be projected. As usual with geoprocessing operations, the outputs are new feature classes and the original inputs are unchanged. Perfect. So inspect the results. Now we can see we have accomplished. So if necessary, we're going to add the parks region layer to here and confirm that the coordinate system is state plane by opening here. I'm going to right click on it, layer, and go to properties and go to source and drag it down, go to spatial reference, and then we can see NAD 1983 state plane California 5 FIPS 0405. So that we have the coordinate system here. It should contain two feature classes, block centroids and parks regional, along with the three bright layers. So it also includes table that river, Los Angeles River perennial. So, and we will save the project. Okay. Click OK first and then go to save. So now we have river copy feature and park block. Good. Okay. Block centroid, river perennial. Yeah, we have it. And line bright. I don't remember line 1. That works. And then parks regional. Perfect. And point. Yeah, 1. And polygon 1. I didn't say bright. Okay. I think that was my fault. I should change it into bright, but it's fine. Okay, we're gonna continue. Prepare the city and county data. So to do that, we will have to do is now we move on to the data that needs more preparation. So in the data requirements table, we listed city, polygon, and county as data needed for the final map. We made notes to reduce the extent because both feature classes cover the entire United States. So the processing data to get rid of extra features or attributes is a matter of choice. We could just as well leave the datasets intact and instead apply appropriate definition queries to the city polygon and county layers in the final map. One point in favor of small datasets is that they generally display and process faster. Likewise, an attribute table is easier to read if it is not clustered with unnecessary attributes, but if later we decided to share the project data with others, it will also be convenient to have a smaller package. So we must be careful in deciding which features and attributes are unnecessary, because once we get rid of them, they are gone at least for that dataset. We will still have the original source data as a backup, so we can recover from mistakes. We probably wouldn't delete features or attributes that won't preserve in another feature class. So now we add a new map and change the coordinate system. Well, that's true. So I can add a map. So in this case, I'm gonna do is go to new map. Then I will right click on it. Okay, right click on it and go to rename. So I name it lesson 4C. So we will change the coordinate system of the new map to the state plane system, and so we will do it is right click on the 4C and go to property and right click the map, open the property dialog box and click the coordinate system, which is right here, and it's gone. So I just have to find it again, project system. And then we navigate. Oh, let's see, favorite. Favorite is gone. Okay. State plane, click OK. Oh, no. Something wrong with me. Okay, go to state plane and 1983 US feet. Okay, and then California. 5. No, that's 4. 5. Click OK. Okay, so and then we will add the data to the map. So we will add the city, polygon, and county feature classes as layers to the map. We will select the feature we want to keep and copy the selection to the new feature classes. So in the project pane in the source data folder, so under Esri geodatabase, we expanded the polygon feature dataset. And we will press and hold the control key and click the city and county, which is geodatabase, boundary, city, and county. Right here. This, okay, drag it. Press control and drag it. Remember, always put on top of polygon. So in the project pane, in the source data folder under Esri geodatabase, we expand this and we hit control. We drag the data set to the map window. The two layers are added to the map. In the contents pane, we click here in the header and select the selected layers. If necessary, drag city polygon above the county. Okay. And change the symbols to color that suits. Well, it's fine. I'm zoomed to Southern California. I'm gonna just zoom here. Southern California, which is right here. And we will select counties. So in this section, we will do definition query, I think. Turn off the city polygon. And we will do, in the contents pane, we will do the county first. Right-click on it and click label. And the counties are labeled by name. So that we can see, and we have the label and the county labeled by name. Label positions change dynamically with the map scale and extent. So ours may be placed differently for sure. So if necessary, pan the map to put Los Angeles County throughout in the middle of the display. So Los Angeles is right here. So I'm gonna just do it here. So Los Angeles. Okay, I've been to Ventura. It's really nice. And Santa Barbara is right here. Cool. Santa Barbara. And then, so I've been all these places. I really like it. Okay, if necessary, pan the map to put Los Angeles County roughly in the middle of the display for sure. On the map tab, we will click the select tool, which is right here. Select tool and click where inside Los Angeles. So Los Angeles is right here. I click here. So select feature is outlining bright blue, so cyan. This feature is probably the only county feature we will need for the final map, but to be safe, we will select the neighbors as well. We will do this using a spatial query. Okay, so on the map tab, we will do is that go to select by attributes. Oh, select by location. I'm sorry. Select by location. So spatial queries evaluate spatial relationships among features. So these relationships include proximity, containment, and adjacency and intersection. So proximity, containment, adjacency, and intersection. And typically features in one layer in the target layer and are selected according to their relationship to features in another layer. And the source layer, sometimes we will work with here. The target and a source layer are the same to that, so that feature are selected on the basis of their spatial relationship to the selected features. So we confirm that county is selected as input feature layer, and it may already be selected. Yeah, it is. So county is selected already and relationship is intersect. So confirm that intersect is selected for sure. Okay. For selecting features, we will click county. So selecting features, that we will put a county, and in selection drop down list, we will click add to the current selection. So add to the current selection, add to the current selection. And we want to keep the currently selected features, Los Angeles County, and select more features. So touching features are considered intersecting. So in plain English, this query means that counties bordering Los Angeles County will be selected and added to the currently selected Los Angeles County. So compare the dialog box in the figure and click Run. So on the map, Los Angeles, Ventura, Kern, and San Bernardino Bernardino and Orange County are selected. Okay, so alright, see. So Bernardino can not Santa Barbara, but Ventura, and Orange County. I think I've been to Orange County, San Bernardino County, and Can. Wow, it's huge. So this is a huge county, San Bernardino. And I want to see the topography. Let's see what's there. So I'm gonna say no color. So yeah, we have some forest, but Ventura. So let's see, Ventura. Yeah, Ventura. Oh, the forest, they burn. Oh my god. So Santa Barbara, right here. A lot of people lost their home along here. So it's really bad. Burn. They do have a lot of forest there. So yeah, Los Angeles County. Wow. But here it's really densely populated. But compared to other, maybe like China and India, of course, it's not that many people. And it's a wonderful place to live, but except the crime. And we will hide the unnecessary fields. So next, so the counter layer will serve a purely cartographic purpose. So that means the only attributes we will need are those we might want for labeling or symbology. So under the contents, we will right-click the county layer and click Attribute Table. We scroll quickly across the attribute columns to see what attribute information is provided. So there are about demographic and economic attributes, none of which we will need. Removing them will tailor the data to its cartographic purpose, so we don't need them. So, and click the Menu button in the upper right corner of the attribute table and click Field View. Alternatively, we can access this view by clicking the Fields button on the Data ribbon. So we can do View, no, Data, or maybe in Data, no. So what we're gonna do is, I think I'm gonna close this out. Open Attribute Table first. Okay. So the attribute table, let's go back to view. Just wait a little bit. View. It's not in view. Let's in edit. Edit cannot. Right here is the attributes. Okay, already be there. So which is right here. That's the option. So we go to option and we will say fields view. Okay. So for fields view, and we will turn off everything. The visible, so here is all fields view appears below the map, where we can customize how attribute fields are displayed on the map. The scrolling box on the left lists the fields in the table. Each field's checkbox can be unchecked. To hide the field, and field visibility is a layer property that we can turn on and off as we like. A hidden field isn't deleted. Nevertheless, the setting affects the way data is copied. When we copy the feature class, hidden fields will be left out. Okay, above the list fields, we will click here, clear the visible checkbox and turn all the fields off, meaning they are hidden in the layer. And we will click the checkbox in the visible column next to name and stay name and turn just 2 fields back on, which is right here. So, and then I only want name and stay name. That's crazy. And you have to save. Okay. So we click the save button and close the fields view pane and open the close this out. So now we only can see the name and stay name, which is cool. And then necessary county attribute table, we will see this, and we will close the attribute table and save the project. And we will continue to copy the selected feature soon. Okay. Go to project and save. And then we will continue.